All right, so this example is very similar to the previous one as far as what it's asking you to do. The behavior of this sequence is much different though. So if we look at the first 6 terms of this sequence, so a sub 1, right, if we put 1 in, we end up with 3 plus minus 1 to the 1. So it ends up being 3 minus 1, which is 2. And a2, so for n equal 2, we end up with 3 plus negative 1 squared, so it becomes 3 plus 1, which is 4. And this minus 1 to the n is just going to oscillate back and forth between positive and negative 1, so we're going to get a3 is equal to 2 again, right? Then a4 is equal to 4, a5 is equal to 2, a6 is equal to 4. Okay, so we're just flipping back and forth. The odd numbered terms are all 2 and the even numbered terms are 4. All right, so if we want to represent that graphically, I'm just going to draw my little number line here. Now in this case, let's say this is 0, and let's say this is 2, and let's say this is 4, right? Because that's where the range of our values is. And so essentially we're starting out at 2, right? So that's a1, and then a2 is 4, right? So essentially a1, a3, and a5 are all 2, and then a2, a4, and a6 are all 4. Okay, so we're just flipping back and forth. 2, 4, 2, 4, 2, 4, 2, 4. Now, does this sequence have a limit? Does it converge? Well, no, because we're just going back and forth between 2 and 4, 2 and 4, 2 and 4. So what we say is that no, the limit as n goes to infinity of a sub n does not exist, right? The sequence does not converge because there's not a single value that it ends up at. It just is flipping back and forth forever between 2 and 4. All right, so I want to talk about in this, I'm going to go over some of the more terminology with you related to these 2 examples that I just did. One piece of vocabulary is the term bounded. We say that a sequence is bounded if there are some numbers k and m between which all of the terms of the sequence lie between, right? So actually both of the sequences that we just looked at in examples 3 and 4 are both bounded, right? So example 3, I can scroll back up to example 3. Our lower limit was 0 and we approached 1, right? So so the bounds of our limit, or the bounds of our sequence, are between 0 and 1. And also this example 4 was also bounded, right? It's always going between 2 and 4, 2 and 4, 2 and 4, right? So it never goes beyond 2 or 4. It never goes less than 2 and never goes bigger than 4. So all of the terms of our sequence are between 2 and 4. So both of those sequences are bounded, all right? Now a convergent sequence is bounded, all right? So we had an example of a bounded sequence that was convergent, right? We had the first example, example 3, converged to 1. So one requirement for a sequence to be convergent is that it has to be bounded. But being bounded does not mean that it's convergent, right? Because you can see we had an example 4, we have an example of a bounded sequence that's not convergent, right? So another piece of vocabulary that is good to know is this idea of monotone. So a sequence is monotone if it's either increasing or decreasing. So each of the consecutive terms is either less than the previous one or it's greater than the previous one. So if it's greater than the previous one, then it's an increasing sequence. So sometimes it's called monotonically increasing. And if the consecutive terms are less, then it's monotonically decreasing. Okay, so that's just some vocabulary. Now, if a sequence is both bounded and monotone, then it converges. Okay, So that's a theorem that's in your book. But you have to be careful with this because if a sequence converges, it doesn't necessarily imply that it's monotone. I mean, we just saw one that goes back and forth, right? Now that one was not that one. Yeah, so we had this sequence. This is not monotone, right? Example 4 was not monotone because it kept flipping back and forth, but it also didn't converge. But there are also sequences that are not monotone, but they do converge, okay? And we're going to see an example in the next, in example 5, we're going to have in 5b, I'm going to show you an example of that. So be careful when you read these because, just because a sequence is bounded in monotone, and then it converges, does not mean that if it converges that it's bounded in monotone. So be careful about these things. All right, so I'll meet you in example 5.